Hey everyone, and welcome to this video on line of best fit in the continuing series on data. So line of best fit is where we take our bivariate data, so we have a scatter plot that we have used bivariate data to create, so remember that's two variables, and we create a straight line that fits the trend of that data. So we call it oftentimes a trend line. And what we're going to do today is we're going to do this by eye. So we're going to look at our data and attempt to draw a straight line within the data that will model it fairly accurately. There's a couple of things to think about when we are doing this. All right, so we're looking at all of our existing data points and how we position our data. Alright, so the position of the line of best fit. So the position of the line should balance the number of data points above and below. Okay, so we should, as much as humanly possible, have the same number of data points both above the line and below the line. In our little example diagram, we can see there is 1, 2, 3 above. There is 1, 2, 3, 4 below. Okay, so it's fairly balanced. It's not quite exact, but if there's an odd number of points, then you're probably going to have it exactly the same, but it's fairly well balanced there. The other thing to think about as well is keeping. All right, so you should always keep, or try to keep, I should say, the distance of each point fairly consistent. So each point from that line consistent. All right, so that way it will very easily, as easily as possible, match the data that we've got there. Okay. Now this line also has an equation. So we have an equation for the line. All right. So the line has an equation. All straight lines on a graph do, in fact, have equations. And we can find this information out using some fairly standard, straightforward algebra skills. So for our y equals mx plus b, which is a fairly standard form of a line in algebra, we can find the gradient, so m being the gradient, by using rise over run, or we can actually use the second y value minus the first y value, which gives us the rise, over the second x value over the first x value, which gives us the run. Okay, so we can use either of those. An alternate version is to use a different form of the equation. So we can actually use an equation that looks like this. So we can use y minus y1 equals m outside of x minus x1. Okay, so we can use that too. I'd stick with the one at the top, using y equals mx plus b and looking for intercepts. Intercepts are easy to find just by substituting in 0 for x. Now, what can we use these types of devices for? Because they essentially are an incredibly powerful tool in data analysis. So once we have the equation, we can do a whole bunch of different things. All right, so this can be used for something called interpolation. I may not be exactly pronouncing that correctly. Interpolation. What this is, all right, is it is talking about making predictions within the given data set. Okay, so this is predictions within the given data set. Okay, within, it's internal. All right, internal of the data. All right, so interpolation, internal. The other thing we can do with it is it's called extrapolation. I fix up my E there a little bit. Extrapolation. Okay, and this is where we're making predictions outside the given data set. All right, so this one's outside the given data set. So this one's external of the data. So external of the data. So interpolation is internal, extrapolation is external. Okay, so now that we have that down, we do have a couple of examples to look at. We're going to look at that in the next video.